We live in an era of technological miracles. The greatest threat we face is not robots replacing us, but our reluctance to reinvent ourselves, says Mike Walsh, a world-class artificial intelligence expert and one of today's MasterClass speakers. My name is Katarzyna Pisarska, and in my everyday life, I'm a social entrepreneur, founder of such institutions as the European Academy of Diplomacy and the Warsaw Security Forum. I'm also a professor at the Warsaw School of Economics in Poland. Today, I have the pleasure to guide you through this extraordinary masterclass organized by Poland's CTN Foundation and Vatican's Pontifical Council for Culture. It is a very special masterclass, at least for two reasons. First, because of its important existential almost topic, the future of man, economy, and the universe. Second, due to the world-class speakers and guests we'll be seeing here with us today. The masterclass will be delivered to you in two separate parts, each constituting 90 minutes. The first part, development, but what kind, will look at the question of where are we going with the world. The second part will consider a new vision of man. So what awaits us? How should we reinvent ourselves into the future? And between these two parts, of course, we will have a 10-minute refreshment break. The whole event is aired to you from Poland, Warsaw more specifically, the European Union. But during today's transmission, we will also connect with so many different other places around the world, with the Vatican, the United States, and Asia. We will welcome representatives of a number of institutions, such as Harvard University, Cambridge University, the Hong Kong University of Science and Technology, and the London School of Economics. Most importantly, however, nearly 3,000 leaders representing 60 global organizations from 100 countries will join us for the masterclass with NASA and the Vatican Observatory, as you can see on this map. So again, welcome everybody. We will be able also to include you, feel your presence here at the time of questions to our speakers, and we're looking forward to them as well. So let us begin. Our first speaker had to wake up before 6 a.m. to make it for today's event. I'm sure you're very eager to meet our heroic early riser. It's no other than Artur Bartłomiej Chmielewski, who is an engineer at NASA, and his initials make him Mr. ABC, and he owes them to his father, a famous cartoonist. Artur, are you already here with us? Hi, Artur. Great to see you. Good morning to Los Angeles. I hope you had a wonderful morning coffee this early in the day. And I always wonder, here's the coffee. And I always wondered, actually, do astronauts get to drink hot, freshly brewed coffee in space? Probably not. We'll ask you that question when we come back to you in just a moment. So now, ladies and gentlemen, let us hear the first part of our event, a preliminary speech of Mr. Artur Chmielewski.
Hello, my name is Art Chmielewski. I work for NASA in one of the NASA centers in Pasadena, California. It's called the Jet Propulsion Laboratory. We are famous at this center for sending such vehicles as Mars rovers and for such missions as Cassini, Galileo, and a lot of other missions. And I had the pleasure to work on most of them. And here is my favorite picture from space. Why is it my favorite picture? Well, it's a picture of Saturn. It's taken by the Cassini spacecraft in 2013. And I worked on the Cassini mission. I worked on a little part called general purpose heat source radioisotope thermoelectric generators. Yeah, it's a mouthful, but I assure you it's a very important part of the spacecraft. And the spacecraft was going to fly slightly away from Saturn and take a picture of it in such a way that we can see all the moons. And then we realized, okay, we'll take a picture of all the moons, but there will be Earth in the background. So he said, kind of jokingly, one of the operators said, look, let your family know that on such and such time, you can just look up into the sky, look at Saturn. Saturn is there. You can't see it because it's during the day, but it's there. And so look at Saturn and wave. Okay. And that was obviously a joke, but the families passed it on to the neighbors passed it on to other people. And pretty soon we were just showered with messages. Which way should I be looking? How should I be waving? And it just swept the entire world. So by the time we let people know that we'll be taking that picture, there were hundreds of millions of people going out of their homes at that time and waving to Saturn, right? Okay, well, that was funny and that was interesting. And we're happy that people were so interested in space. But there's one more thing that made this picture my favorite picture of all of the space pictures. And that is that you can see the Earth there. And the Earth, you'll have to look for it. You would probably have to expand the screen and look for it. It's right there underneath on the right side of this picture, underneath the outermost ring. And it's a tiny, tiny dot. It's probably 1 pixel. You actually, we call it here at JPL Moon Earth because both are in the same pixel. And it makes you think that we're a tiny blue dot in space, right? This is only from Saturn, and cosmos is huge, humongous. We're still within our tiny little solar system, and the space is just tremendous. So I put up this picture in my office, and when I'm unhappy about something, some little thing, or somebody makes me angry, I say, how could he be saying something like this? I look at this picture and I say, we are a tiny little dot. Our Earth is a dot. I mean, how could I be unhappy about few words or something so insignificant? And it brings the things for me into perspective. And especially these days, I'm really happy about space because space is changing. Just like computers were changing about 50 years ago. Computers 50 years ago were humongous machines. They were of the size of a maybe typical room or living room. And they were just huge and they were very expensive. They were maybe at only top universities could afford them. Departments of Defense use them because their prices would go into hundreds of millions of dollars. And their programming and operation was very difficult. And they were used for the most difficult calculations. These were the computers 50 years ago. And quick fast forward to now, and we have, so what do we have? Everybody has a computer in his or her pocket, right? These are computers, and some of them are more powerful than these computers that were called supercomputers 50 years ago. And why am I talking about computers? Well, a lot of people may have not noticed, but the same thing is happening to space. We call it democratization of space. What does it mean? It means that you can build a spacecraft now and launch it into orbit for the price of a car. Right? This was only reserved for NASA, Russia, European Space Agency just several years ago. The spacecraft were very expensive, very big, difficult to launch, extremely difficult to build. Now a university or organization can build a spacecraft, launch it into orbit. Is this a threat to NASA? Is that a threat to us? Absolutely not. We're extremely happy that this is happening. NASA wants to only build the most difficult missions, right? We want to build this first of a kind where you need to have this incredible technology. We want to answer and do things that are incredibly difficult, that are very risky, and the technology, when we first talk about it, is maybe not different from magic, right? And then magic, what is beautiful about answering these challenges is that pushes scientists, pushes engineers, pushes programmers to solve these most difficult problems. And in the process, they invent things. And in the process, they build things. And in the process, they create this technology that maybe initially sounds like magic. But then it goes into the marketplace, and it fuels the countries, fuels companies, right? I mean, the simplest example of this is what we all have next to us right now, the smartphones. The smartphone would not exist. The Apple did not invent really anything. They just put together a few space technologies, like a miniature hard drive, like the space communications, right? Everything came from government programs, and everything came from space. And now this is a company that probably has budgets higher than most of the countries and fuels the economy. So this is a wonderful thing about space, that it produces these inventions, right? That helps the economy. What is also wonderful about space and how and our missions into the farthest places in the universe, well, maybe now also into the solar system, but we are looking at extrasolar planets, is that not only the technology is developed, but that kind of expands our thinking about the world. It expands our knowledge. It expands eventually the understanding of our own planet. So when we go to Mars and we look at Mars and we say, okay, wow, we just discovered that Mars had rivers, lakes, maybe even an ocean. What happened? We don't know yet. But through space missions, we'll find out. I assure you that we'll find out what happened to Mars. And then what happened at Venus? How come Venus is so hot? This spacecraft only can survive right now a couple of hours on the surface of Venus because it gets crushed with pressure. It boils with high temperature, and then it gets dissolved in sulfuric acid. A terrible place. Venus is an incredibly difficult place to survive for any life or even a machine. But what happened there? And we don't want Earth to be just like Venus or like Mars. So we want to understand it. And we want to apply invented technology, use this technology to study the universe, and then apply it to improve the life and quality of life on Earth. And by looking at a picture like this Cassini picture, we also want to send the signal. We want people to think about it and say, we are a tiny blue dot. We should all get along. We should work toward peace, toward making our life better, into protecting our planet. And it's a universal picture of peace, of moving forward, gaining knowledge, and using this knowledge for really good purposes. And I am very proud and very happy that maybe I can make tiny contribution to that challenge. Thank you so much.
Thank you, Artur, so much for making, I think, 3 key points. That on the one side, we are just a tiny dot in space, but also that the space is changing. We see a democratization of space. And last but not least, you said what we know, exploration of space not only changes our perception of humanity, of ourselves, but also contributes to the economy. I hope to speak with you in just a moment about all 3 elements, but let me first introduce to you and to the audience our guests here with us today who will be contributing to the discussion, both online and here in the studio. So let me start with introducing our online guest. Our first online guest is connecting with us from the Vatican, and more specifically from Castel Gandolfo. It is no other but Brother Guy Consolmagno, who is the director of the Vatican Observatory and a science fiction fan, as I understand. Good morning, Brother Guy. It's wonderful to have you here. And I hope you will be able to tell us more why the Pope needs an astronomical observatory in the contemporary world. I'm sure our audience is very interested in this question. Second with us, you can also see, is a man who in 2008 won $1.6 million. And he did not win this in Casino Royale or in a ticket lottery or even not in a computer game. He actually received a scientific prize, the American John Templeton's Foundation Prize, for his extraordinary achievements in cosmology. But what is more, there's one more ace in his sleeve. He is a Catholic priest. I wonder, and this is one question that we had from one of our leaders, whether if we would have extraterrestrials here coming to the world, would you decide to baptize them and convert them into Christianity? Maybe we'll talk about this today. So with us, Professor Michał Heller. Wonderful to have you here online as well. And of course, you can also see Artur Chmielewski here. Let me also introduce to you our guests here in the studio. On my right, I will start with Andrzej Dragan, who is a physicist, but also an artist. He's a photographer, composer, filmmaker, a professor at the Faculty of Physics of the University of Warsaw, and a visiting professor at the National University of Singapore, a self-professed atheist. I think you are the one who has remade the Catholic Church catechism into quantahism. That's something I'll ask you about a bit later. On my left is no other than Professor Krzysztof Zanussi, a world-renowned film director, but also a person who represents the organization who is the organizers of today's event, CTN Foundation. So thank you, Professor, for organizing this incredible discussion. We also know that apart from your great love to movies and filmmaking, you are also a philosopher. You are also interested in physics. So I'm sure this will be a fascinating discussion. And last but definitely not least, Professor Krzysztof Meissner, who is a professor of physics at the University of Warsaw in Poland. He collaborates very closely with Nobel Prize laureate Sir Roger Penrose. I heard that Sir Roger actually makes pancakes when you meet and you talk about cosmology and you talk about the universe. So I'll ask you about this in just a moment. But before we start our discussion, I want to turn back to our first speaker, Artur Chmielewski, with a first question, and then we'll ask our other guests to ask more questions to what you've already said. My first question to you, Artur, would be the following. We just heard yesterday news that there's a big asteroid coming in the direction of Earth. It's not the first asteroid, but this time it seems that the likelihood of a collision is less than 0%. It is 1%, 2%, we don't know yet. It's a huge asteroid. But tell me, looking from the point of view of NASA, do you think these kind of potential existential threats that come from space, do they change the way we perceive the world? Do they change the way we perceive ourselves? And how do you actually in NASA take on these kind of news that surely many of us fear?
Well, first of all, I wanted to thank you for inviting me here. I feel very privileged. Privileged by the challenge of answering so many interesting questions about space, and the privilege of being with so many distinguished personalities here. So thank you so much. And maybe I should be asking questions, because it seems there is so much expertise in the studio and out there in the internet land, that maybe I should be asking questions and taking notes. If I can contribute something, I will. For example, well, I can tell you how we look at the asteroids and upcoming objects here on potential collision course. We always have to be very precise that and warn everybody that this object is just on a potential collision course. That's not going to happen. We don't want to cause panic. Stock market drop.
So we can sleep well.
That's right. Although I have these exercises with students when I sometimes go to colleges and at high schools, I ask them, okay, what do you think would be impact on the world if we knew that, and they have to draw out of their hat different scenarios, that the asteroid is tiny, the asteroid is big, it will destroy California, it will destroy one continent, it will destroy the whole planet, and it's coming in 3 months, 3 years, 30 years. How is it going to change life on Earth? It's a very interesting question. The impact is psychological, economical, right? Technological. I mean, would all the world's money and all the efforts go into saving the planet, right? Would we? One benefit, I think, of this would be that for the first time, the whole world will be focused on working together to solve a problem.
You know, Artur, looking at the pandemic, I'm not sure if even a disaster of the pandemic proportions, we sometimes weren't able to look eye to eye and work together. I wonder if an asteroid would actually make that difference. Professor Heller, please tell us, what do you think?
Hi, Artur. I have a question, actually, which is very, I think, crucial. Namely, we know that in the past, the space exploration was the source of enormous technological breakthroughs and so on. What is the technological breakthrough that you would think would be a game changer, that would really change our perceiving of the cosmos, the space exploration? What would be something that you would wait for that would really change the whole game of what we are looking forward, what we are expecting from the space exploration?
So actually, these two questions, the first question and the second, maybe could be combined. Because definitely we're watching the space all the time. We have telescopes mapping the asteroids, any upcoming objects, any objects in the orbit that is changing. And there are a lot of them. There are chunks of asteroids. Of course, comets are very unpredictable because they puff out jets all the time and change their trajectories. So it's very difficult. And as a matter of fact, there's a JPL team led by somebody who has Polish descent, Jan. He's, I think, was born in Canada, truly international man, but he leads a team of experts who are looking at what's coming to us. Because, you know, people think, oh yeah, there was an asteroid 67 million years ago. It killed dinosaurs, but that's such a long time ago. It's so unlikely. We don't think about it. But if you are at night and you look at the moon, what do you see on the moon? You see craters, right? The first thing you see is craters. And so how did these craters form? Well, from impacts from asteroids and comets, right? And we are in the same statistical neighborhood as the moon. It's just that we don't see these craters on Earth as much. Well, there's one in Arizona, there was Tunguska, right? There was Chelyabinsk, and there was, of course, Yucatan Peninsula. But we don't see this, but Earth gets impacted by these asteroids all the time, just like the moon is. So, we're going to get hit sooner or later. Is this sooner 200 million years or 67 million years or 67,000 years? We'll see. But certainly, the discovery of an asteroid on a collision course with Earth would change our perception in space and our importance of space. What else? Well, certainly discovery of one microbe, one bacteria, or some living organism. And we are looking for, of course, NASA is looking for life everywhere else beyond Earth. That would philosophically change our view of the universe. It would mean that probably statistically, again, the universe is teeming with life. Now we think that that's probably the case based on statistics and how life originates the way we understand it. But we don't have a proof, right? So everybody can have his own theory and is agnostic.
Yeah, so you're saying two things, a asteroid on a collision course with Earth, and of course, finding any proof of living life would be a game changer for humanity. I wanted to turn here to Andrzej Dragan, who also has a question to ask to you from the studio.
Thank you, Arthur. It was very interesting to listen to this beautiful introduction, but I have a little bit of a comment. So you mentioned a lot of side effects of the space race that we are involved in, but there is one more tiny reason why we actually need to go to space, and that's because we owe it to the fish. Our ancestors, who millions of years ago were involved in great sacrifice to leave the oceans, crawled out of the waters to inhabit the lands. It was paid with countless lives and suffering, and only because of that suffering we are now able to walk the earth, enjoy the fresh air, and only because of that, only because of those sacrifices. Otherwise we'd be still sitting in the oceans. So I guess the only way to pay that debt now to the fish is to do the same, just to explore the outer space. And on the more serious note, I think the main reason to do that is not because of those side effects that gives us technology and the reasons to, to expand our technical abilities, but it's rather to fulfill our curiosity. Because this is why the fish crawled out of the sea, not to create technology, but to fulfill the curiosity. And we have to do the same.
Thank you, Arthur. A short answer, 2 minutes, because we have an online question coming up.
It's very interesting that you bring up oceans. Oceans are very important. Water is very important to life. There are 3 things that are required. We know that for sure for life. That's water, hydrocarbons, and energy, right? Water is one of them. So oceans, right? And this is what has changed in the last few years, 10 years, 15 years. We always thought, looking at Earth, 2/3 of our planet is covered by ocean. Well, no wonder that this is such a nice place to live, right? And all the other places we look at, Venus, it's a terrible place with sulfuric acid and temperature, right, and pressure. And Mars is fairly dry. But it turns out there's plenty of water. And we even have a program now called the Ocean Worlds. And we're sending probes to a lot of places in the solar system just because we discovered that there is this water. It's just this water is not in the oceans that are on the surface, but frequently in a lot of moons and such like Europa, Ganymede, and Enceladus. It's all hidden underneath ice. But there are these huge undersurface oceans. The ice protects it from radiation. There's water, there are hydrocarbons there, and there's energy from all kinds of volcanic events and friction and other things. So we know that there's water, energy, protection from radiation that is deadly, and energy in so many more places in the solar system and universe than we thought before. So oceans are definitely very important.
So we owe it to the fish, but also to the oceans. Thank you, Art. And we have one more question coming up. This time we're connecting with the Hong Kong University of Science and Technology. We have Stacy Wong with us, who wants to ask a question. Stacy, please.
Thank you for your presentation. And here is my question. The greenhouse gases in the atmosphere of the planet Earth require major correction. So what can scientists learn in space exploration that can help other scientists to have a paradigm shift in our atmosphere? For example, leading them to think out the box.
Excellent. Arthur, did you hear the question? The question related to something so important to us today, the prevention of further climate change. How can NASA and the technology you're using help us to counteract this huge existential, to some extent, challenge that humanity faces?
So what is wonderful about my organization is that, yes, we are famous for sending men to space. We're famous for these rovers on Mars. But actually, a lot of this technology is used for our daily benefit and for understanding our planet. It's doing things for the benefit of our planet. For example, most of my career at NASA, I worked on interplanetary probe, to Jupiter, to Saturn, to comets. Right? And it's really fascinating because everything you learn is absolutely new, something that we speculated, thought about, but never knew what really is the truth, right? But then now I'm working on for example, on a mission. It is fascinating for a different reason. This is truly an important mission for humanity. And this is one of the very few Earth science missions that I've been working on. And this is called OASIS. And a lot of people don't realize, but NASA has many, many satellites in orbit that investigate Earth and climate change, which is extremely important. The mission OASIS that I'm working on and will be maybe launched in about 5 years, we'll be looking at a couple very important things that deal with climate change. One, we're going to use technology that we've developed for Mars. We talked about it, that we are looking for water on Mars and has life existed on Mars, right? That was an interesting scientific question. But now we decided to use the same technology to look for water under Sahara Desert and Arabian Peninsula. So these are very water challenged areas, right? And we don't understand how much water is there. There is water under Sahara, right? Extremely important humanitarian question. I mean, just imagine if this whole region where 500 million people live will start running out of water, and it's starting now. The deserts on Earth are getting drier, and the icy regions and wet regions are drying out also. And the same mission will also look at the melting of the Antarctic ice. So the sea level rises because ice melts, right? So that's a question that we have to understand. How much of this ice will melt? How much water will go into the ocean, and the ocean level will rise? And what people also have to think about that as the ice melts and ocean level goes up, oceans have a lot of salt. So as they impinge on the coastlines and on land, they also start contaminating the fresh water supply. So this is one of the climate change consequences, which is really severe, that water that we need so much, and again, we talked about oceans just a few minutes ago, water is essential to our life. And we're going in a wrong direction, contaminating it and not using it properly and not protecting our planet. Mm-hmm. So NASA observes a lot of parameters from space of our planet and tries to improve all the climate change predictions to help humanity.
Thank you so much, Arthur. This is really excellent. Thank you for being with us in this first part. I think we've learned that NASA is not only responsible for space explorations, it's not only responsible for the growth of our economy, but we see now also a very growing role in trying to help us face the challenges we have here on Earth, yes, without space exploration. So, Arthur, thank you. to you. And we move on now to the next speaker of today's program. I've already introduced him to you, Father Guy Consolmagno, who will give us a short introductory remarks, and which will be followed with a discussion with our experts here in the studio.
Hi, I'm Brother Guy Consolmagno. I'm a Jesuit brother and an astronomer. In fact, I'm the director of the Vatican Observatory. The fact that I'm here in a clerical collar with my MIT ring tells you that it is possible for one person to be at the same time both a fanatic and a nerd. The fact is, I'm something of a fanatic when it comes to my science and a bit of a nerd when it comes to my church. The fact that I do both can seem surprising to people, and sometimes I might get the question, why do I believe in God as a scientist? I want to turn that around. The question isn't, why do I believe in God? But why do I believe in science? Because I do believe in science. That's a brave thing to do nowadays when people try to throw up doubt about science, but I believe in it. And I believe in it so much that I'm dedicating my life to being a scientist. But why? What actually is the science I'm doing? You know, astronomy, the study of the sky. A cynic might say, no, your astronomers don't study the sky. They study what other astronomers have said about the sky. And there's a lot of truth to that. I spend a whole lot more time reading papers or going to talks or overhearing what other people have talked about in their studies than actually looking at the sky myself. Does that mean that I'm just believing a lot of things that other people have made up and I'm making up more things for other people to study after me? Are we actually really getting to the truth? Why do I think that there's truth in the astronomy I'm doing? I use the word belief in my science, and I do that for a reason, because science is a system of logic, and every system of logic has to start with axioms. They have to start with things that you assume before you can even do the science, just like a syllogism has to start with a major. What are the axioms that you do when you do science that you believe without even thinking about it, that fundamentally are religious axioms? One, you've got to believe that the physical universe actually exists. It's not just an illusion. I'm not just a philosopher dreaming that I'm a butterfly, or a butterfly dreaming that I'm a philosopher. I believe that what I am studying is real. Secondly, I have to believe that the universe actually makes sense in a logical way that can be described by laws. And not all religions believe that. The ancient Greeks and Romans, they believed in gods that threw lightning bolts. If you see a bolt of lightning, you don't work out Ampere's law in Maxwell's equations. Instead, you say, the god of lightning threw the bolt. Explains everything you see. And there's no way that you can test that that's wrong if your fundamental assumption is the universe is full of nature gods. But if you refuse to believe in nature gods, maybe because you believe in only one God, then you've got to come up with some other explanation. But you also have the room to say that there are laws, that there are other explanations to come up with. And the third thing you have to believe is that it's worth doing it. That instead of going out and making lots of money or fathering as many children as I can, instead I'm going to spend my life studying the physical universe. Where do I get this from? I get it from my scripture, from the book of Genesis that says God created the universe deliberately, step by step, in a logical way, every moment of the day, saying it is good. And at the end of the period of creation, created the day of rest, the Sabbath, to give us time to appreciate this universe. But then I could be a poet writing poems about the universe. I could be an artist painting the universe. All of those things are good things. Why am I doing it as a scientist? Why do I think I'm going to get truth doing science? Where does my faith in science come from? Does it come just from authority? Because my teachers told me that the science works? For a lot of us, that's certainly where it starts. Do I say, science, I believe in it, I've got faith in it because it works, it gives me the right answer? That's a kid's answer. That's the kid who thinks that science is getting the right answers in the back of the book, that science is nothing but a big book of facts. So that's not science any more than playing scales is playing music. We use these science books to get us up to speed, to teach us how to do the science. But the science itself is an adventure involving things that we don't know, things where we don't know if we're going to be right. So it's got to be more than just it works. Experiment, repeatability. We can do something in the laboratory and we always get the same result. You ever been in the lab? That never happens. There's always something goofy that goes wrong. You probably have even saw that when you were a student trying to make the right answers in the lab. The fact is that when things go wrong in the lab, we spend a lot of time trying to chase what went wrong because we are fundamentally assuming that there's a reason for it to go wrong, not just that, the nature gods were nasty that day. Where do we get that faith? What is an interesting way to attack this is to recognize that the things that give me confidence in science, what counts as strong evidence for a given theory, what gives me a belief that I'm on the right track, are the same tools that we can apply to our faith in God, that we can say, this is why I believe in God. Have you ever changed your mind? Have you ever admitted you were wrong about some scientific idea or theory or something else in your life? What did it feel like? What made you do it? What gave you the impetus to say, no, it's got to be more than that? There are things in science that give me confidence that my science is right or encourage me to find something better. One is a wider applicability. If I have one solution that solves one problem that suddenly solves 5 or 6 others, then I can say to myself, maybe there's something going on here. If it's repeatable, not just that I can go to the lab and repeat it, but that other people studying the same problem have come up with the same answers over and over and over again, that gives me confidence that I'm doing something that's right. But there's another element that any scientist will tell you about, after a couple of beers and it's late at night. And that's a scientific theory has to be elegant. It has to be beautiful. It has to fit together like a beautiful machine or a beautiful painting or a beautiful piece of music. Some people reduce this to Occam's razor. The simplest solution is the best. But where do you get the idea of simplest? What's simple to one person is complicated to another. It's a human instinct. It's that human feeling that, this is so gorgeous. There's got to be truth in here someplace. And so that brings me back to my original definition of what's astronomy, the study of what astronomers have learned about the heavens. Because astronomy is ultimately a human conversation. It's a conversation among thinking, feeling, emotional, but rational people looking at the universe, searching for understanding, searching for beauty, searching for joy. But like every good conversation, it's open-ended. It involves more than one voice. There's no one right answer. There's no one place where you say, solve that one. Don't have to look at that anymore. You continually revisit in the light of new things that you've seen. And why do we do it? We do it for joy. We do it for love. We do it for the truth. And love and joy and truth are the markers of the presence of God.
Thank you so much, Father Consolmagno, for making the argument that science may be an act of faith. We have our first guest here in the studio that has a question to you. Andrzej Dragan, please.
Thank you. So I have been a quantum scientist for over 20 years, and I must say I have no faith in science whatsoever. And you know why? Because science doesn't need my faith at all. Because the fundamental principle of science is to doubt, is not to have any faith, is to disbelieve and question everything you can question. This is what is basis of science. Science is founded in doubt. And you don't need to believe in anything, really, if you want to do science. And another reason why science does not need your faith comes from St. Matthew, who noticed that you can actually judge, you should, or is it reasonable to judge things by the fruit? So let's try that. The fruit of science is that since the onset of science 400 years ago, it resulted in us naked apes landing on the moon, building a almost building a quantum computer, performing quantum teleportation, doing all these marvelous things. And as a side note, building internet, computers, Facebook, all these things. So this is another reason why science does not need your faith. You can judge by the fruit. This is enough. It's just working. And there are no absolute truths in science. Axioms that you mentioned can change overnight, which happened with relativity, which happened with quantum theory, and we just realized our axioms were wrong. We changed them overnight. And there is no reason to think it won't happen many, many times in the future. So we don't really have a reason to have faith in science. It just proves its worth itself. And as much as I understand your intention to blur the lines between religion and science, I don't think it's really necessary, because having faith in science is really unnecessary, if not inappropriate.
So
it's an interesting point you make. Actually, Paul Tillich, a famous theologian, wrote at length on the necessity of doubt in faith. But what he said could actually be was summed up by an American writer, Anne Lamott, who said the opposite of faith isn't doubt. The opposite of faith is certainty. If you were certain, you wouldn't need the faith. It's precisely because we're not certain, precisely that we do have doubt, but we have a belief that we can resolve those doubts and learn something more. That's the faith that we need. I'm not even talking about a faith in God. I'm talking about a faith in the process. Furthermore, the reasons why we as human beings want to do the science are reasons that go beyond the functionalities, the sorts of things you're talking about. You're talking about technology. And technology is lovely. I'm delighted to have technology. But technology is not the reason why we do the science. It's one of the lovely fruits of it. But again, the same science that gave us these marvelous technologies has also given us worldwide pollution, climate change, and abuse of the environment. In the past, they gave us, the horrors of World War II. So you can't look at these fruits and say that justifies. There were people who would say this justifies not doing the science. Oh my gosh, there are things we shouldn't have known because it gave us the atomic bomb. I think that functional view of the universe is a very narrow vision that neither inspires us to look further nor allows us to appreciate the joy that we have when we do look further.
Yeah. Okay.
Thank you, Father Consolmagno. We have another question here from Professor Meissner.
Hello, Guy. So I fully disagree that we don't need faith in science. We have to believe that there are laws of physics. If there were no laws of physics, anything else would be completely futile, and if scientific research will be completely nonsensical. So we need a faith that there are laws of physics behind or below everything what we see. That's a faith that we have. The second thing that I would like to defend the Greeks. You said that Greeks and Romans had lots of gods and so on. Without the Greeks, we wouldn't have science. They made two absolutely fundamental contributions. One of them is abstraction, that whenever I have 3 and 4 and 5, there will be a rectangle, there will be a triangle with right angle. It doesn't depend whether it is a silk or a rope or whatever. So abstraction is a fundamental thing. The second is Plato, that we have ideas that are objective, that are eternal, that are absolute, that are that beyond something that we see, there are ideas only, and these ideas may be laws of physics, but they have to be there. Otherwise, our observation would be just an observation, nothing else. The science is possible because we have objective ideas behind the world that we see, and that's what the Greek gave us. So I would like to defend the Greeks.
I will go even further in expressing that the even greater thing they gave us was the room to ask the philosophical questions, the space to say, not only how does it work, but why does it work that way? And so obviously we could not have done the things we do without the Greek philosophers. The Romans gave us marvelous technology and a big enough, stable enough economy that we were able to apply this technology. Roman science really was mostly Greeks working for the Romans, I have to confess. And being an half Italian myself, I recognize it's not one side or the other. The mathematics that we got from the Hindus was essential. But also the philosophical setting in which we do the science is essential, because science ultimately is the activity of human beings. And if we don't have human beings able to talk to each other and giving each other the room to ask the questions and to question the answers that others have had, then science doesn't happen.
I feel also Andrzej Dragan wants to give a counter argument here.
So in his famous quote, Albert Einstein said that the most incomprehensible thing about universe is that can be understood, that it is comprehensible. So it seems that it surprised him that universe has some laws that we can understand. So this is not really our fate. We don't need to have faith that those laws exist. It's our discovery that there are some laws of physics. And by the way, we are not entirely sure whether this is completely true. For example, in quantum theory, there are no laws of physics that can predict every single outcome of any measurement. Right? There are situations in which there are no laws of physics predicting given situations. And this is our discovery. So we happen to discover that not everything is governed by a law, and we just have to accept it. We don't have to have a faith in that. We just study how it is and just accept how it is.
But if it was completely random, we wouldn't make physics. That would be completely nonsensical.
Of course, but this is our discovery that universe happens to be possible to be described in physical laws. Not our faith.
Not only that, you wake up in the morning and you know that the sun will be there, that you can walk because the laws of physics didn't change. Our existence is based on this faith that the laws of physics are universal in time and in space. That's an absolute fundamental faith that we have. We cannot predict that in an hour or so everything will change, because being a physicist would be a nonsensical profession if I assume that every hour something changes and it's completely chaotical.
I would say that we just discovered this. This is the discovery. We don't know why.
Absolutely. Professor Zanussi, here from a more cultural perspective.
I wonder what is my perspective, but I hope I don't break the rules of this debate. If I address you, Professor, as a priest, not necessarily as an astronomer, because you provoked me because you quoted Book of Genesis. So I wonder, what is your intuition? How would you explain creation of man as a final act? Is there any room for evolution that would lead us to some better species than humans? Or is it absolutely closed question?
I'm never going to tell God what God can do or not do. And my joy as an astronomer is to look and see. But in the human being and in any other entity in space that has the traits that the philosophers of the Middle Ages described as intellect and free will, self-awareness, awareness of others, and the ability to make free choices. Those are the traits of the soul. Anything else is artificial, whether or not you've got a white beard or 27 tentacles. That doesn't matter. It's this ability to recognize your own existence, your own awareness. In creatures like us, the universe itself has become self-aware. And of course, we're going to grow. Each of us as individuals grows and changes. The story of Genesis is not the story about creation. I just took the best science of the Babylonians that was around at the time. The story of the Genesis is about God. And it's about how God deliberately chooses to have entities like us who are self-aware and who, the climax of Genesis is not the creation of human beings. That's only the sixth day. The climax is the seventh day. when we can make the discoveries, when we can ask the questions, when we can enjoy the argument.
Thank you so much. And we now are connecting with our online audience. We have one question. Mrs. Anna Białas, a graduate of both Harvard and Oxford University, has a question to you, Father.
Thank you guys so much for sharing your thoughts with us and reminding us what science really is about. It's an adventure that involves things we do not know about, learning from when something went wrong, and never settling on the right answer at the end of the book. Guy, in your talk, you mentioned 3 axioms of science: the belief that physical universe exists, the belief that the universe makes sense in a logical way that can be described by laws, and the belief in the work of doing science. You call them fundamentally religious. I would like to ask you how people without faith can do science and discover the truth. You also say that your motivation to study the universe comes from the book of Genesis. If you were to wake up tomorrow without your faith, would it still be worth doing science? Thank you very much.
Guy, the floor is yours.
Right. It actually happened when I was 30 years old, and I was a postdoctoral fellow at MIT. And I lost my faith in science, not that I didn't believe in the science anymore, but I didn't believe it was worth doing. I looked at the world and said, there are people starving in the world. Why am I wasting my time worried about these ice-covered moons that we heard about earlier? So I quit science, and I joined the US Peace Corps. This was long before I entered the Jesuit order. The Peace Corps sent me to Africa. I wound up not only teaching at the University of Nairobi, but also I wound up talking to people up country, and I had a little telescope, and they would look through the telescope and they would see the rings of Saturn, and they would go, oh, wow. And they would say, what do we know about them? What have people told us about them? What have we learned about the rings of Saturn? And I realized it didn't matter if they were remote villages away from the nearest university, or students at the university, or my friends back in America. As human beings, we all had the same curiosity and the same delight, because we didn't live by bread alone. The thing that makes us human is this curiosity, this not being satisfied with the answer. And so that, to me, makes me realize that that is key to anyone who's doing science, whether or not they want to use the word faith, whether or not they want to use the word religion. The funny thing is that most of the scientists I've encountered since I became a Jesuit, and they said, oh, you go to church? Let me tell you about my church. A lot of us are churchgoers, but even beyond that, all of us believe in truth. We would not fake the data to get ahead and think that that was good science. All of us look for the joy that comes from doing the science. Otherwise, we'd stop doing it and we'd go work for a bank and, wind up being able to buy a nice sports car, maybe. At the end of the day, though, and again, I'm quoting a Jesuit theologian, Michael Buckley, to be an atheist means you have to have a very clear idea of the God it is you don't believe in. And there are a lot of versions of God out there that I don't believe in either. I only believe in one God. So I'm very close to the atheists. We're not that far apart. And the God that I do believe in, though, is a God for whom truth is central. Beyond that, why would I be a member of the Jesuit order? Why would I be a scientist?
Father Castelmagno, thank you so much for being with us. It was fantastic to bring in also the question of religion and faith, how they interlink, although we might not have all agreed that science is an act of faith. But I think it's a very important perspective to our discussion. And now, ladies and gentlemen, we move to the final speech of this part of the masterclass, which is a speech prepared by Professor Michał Heller. Panie profesorze, the floor is yours.
The importance of the question about the meaning of life need not be justified. It is one of the most important questions that exist. Related to this question is another one. Does the universe make any sense? They actually pose one big question. After all, it is the universe that generated the human being. The information that makes us who we are has been inscribed into our genes through long evolutionary processes, tightly woven into other cosmic processes without which it could not exist. The question of the meaning of human life and of the meaning of the universe are but two faces of the same question. Is the universe a blah blah blah, just a sequence of processes without any meaning? Far from it. And let's do a little experiment. And suppose we want to enforce the universe to do something stupid. Something which was not included into its program or into its initial conditions. So for instance, I pick up a stone and throw it in any direction and with any force, completely at random. I did something that the universe did not know in advance and could not have predicted. But as soon as I threw the stone, the universe incorporated it into its very structure and made it move in a very organized manner. Its trajectory is a solution to Newton's equation of motion, and the initial conditions for this solution were determined by my hand, giving the stone specific direction and specific velocity. Everything that happens in the universe is subject to mathematical laws. The universe is mathematical or mathematically rational, as we are used to say. Even what we call chance is integrated into laws of mathematical calculus of probability. Everything in the universe is mathematical. We usually consider the property of rationality as an element of meaningfulness. In this sense, the mathematical rationality of the universe can be regarded as a manifestation of its meaning. We can call this aspect of meaning the cosmic meaning or cosmic sense. Of course, the human being participates in the cosmic sense because human being is himself a part of the universe, and the human history is but one of the fibers of the cosmic process. However, when we are speaking about the meaning of life, we are asking for something more. It's not enough for us to be a part of a mathematical blueprint. It's not enough for our body and our conscious brain to function according to the mathematical laws of the universe. Our point is that our existence should have the meaning just like words or sentences have meanings in the language. In this context, we can speak about the existential meaning or existential sense. It is logically quite possible for the universe to be cosmologically meaningful, that is rational in the mathematical sense, but devoid of any existential meaning. It is logically perfectly possible. However, logically possible does not mean cognitively satisfactory. A mathematically organized universe with a precisely functioning conscious brain as part of it, but devoid of any existential meaning, would be something dangerously close to contradiction. Through the senselessness of human existence, the absurd would infiltrate into the rational structure of the universe. Let us then consider the other possibility. The existential meaning of the universe and that of human being remain hidden for us. We still do not know exactly what it is, but if we accept its existence, the universe is no longer an absurdity, but a mystery. Mystery in this sense is not an excuse of our ignorance, but rather an opening up to a rationality that transcends our capacity. It is obvious that with the eyes of religious faith, things can be seen in the world that are invisible to the scientific method. For the believer, the universe is not only a set of physical or biological processes, but is also the work of a rational being, of God. This entitles us to assign to God a purposeful and meaningful action in analogous but not identical sense in which we speak of a meaningful action with regard to rational human activity. However, we must always take into account that this purpose may partially or completely go beyond our cognitive abilities. In the religious perspective, every person, from beginning to end, is immersed in environment of meaning and in environment of mystery. But in order for that meaning to be my and not God's meaning, I must choose it and try to make it real in my life, always, even when the light of meaning ceases to be clearly visible.
Professor Heller, thank you so much for bringing to our discussion a very important question, the meaning of the universe. Why are we here? Why does the universe exist itself? We already have a number of questions we want to ask you, and I'll start with Professor Zanussi here.
Thank you very much. Well, Reverend Professor, I say Reverend because you're also a priest, what is quite remarkable. And you spoke about rationality and sense. And there is no doubt that reason is a principal cognitive instrument of human mind. But what about another instrument so deeply rooted in various religions like Christianity, Judaism, Islam, Hinduism, and others? This other cognitive instrument may be called mystical experience. And where do you situate mysticism? Is it complementary to reason? Or is it contrary to reason? Or is it irrelevant for the reasonable mind?
I think that, as usual, things are much more complicated. Let us notice that there is another word than mysticism, which is closely related to it. I have in mind the word contemplation. It's an aspect of mysticism. And my point of view is that in doing science, there is a lot of contemplation. That is to say, there is a lot of mysticism of a special kind. It's interesting to notice that the word contemplation is a Latin translation from the Greek word theory, theoria. And what is more, Plato believed that the human soul has an insight into the world of forms, into the world of ideas through the theoria, through contemplation. And I think it's not just a chance that the word theory has such a magnificent meaning in science. Science is all directed to find out new and better theories. So we contemplate the universe in that way. In doing science, it's part of mysticism. And take, for example, the attitude to science of Einstein. It was full of mysticism. We have alluded even today to the praise often repeated by Einstein that the most ununderstandable thing in the universe is that it is understandable. This is a true mysticism. And as far as the mysticism in the religious sense is concerned, I must admit that I have a lot of skepticism with regard to it. I think that in many cases it is just an exaggeration, and everything can be explained with the help of psychology, which does not contradict the fact that God can use natural causes to speak to humans.
Thank you very much, Professor. And again, bringing the physical and the spiritual, which at some point actually come together. Professor Meissner wanted to say more about this.
Witaj, Michale. I would like to, in a sense, bring in the question of Gödel theorem. Namely, it says, of theorems, they say that there can be infinitely many sentences about the world that are true but unprovable. Therefore, maybe the existential meaning of the universe is one of those, that we can understand it, we can, in a sense, it's true, but it's unprovable. What is your opinion about this fact that we can say or we can formulate infinitely many sentences about the universe that are true but unprovable? What is the way actually to say whether they are true but unprovable or they are unprovable but wrong?
I must say I like and admire your way of contemplating the universe and science, but I would prefer more, more humble approach to Gödel's laws. The Gödel's theorem refers only to axiomatic systems. And science as such is not an axiomatic system. So Gödel's theorem refers to some small part of science which can be formalized, in which we can distinguish initial axioms, rules of inference, and theorems, and then we can say that there are some unprovable things within that system of axioms, provided it is rich enough. But I think that I like to think about mathematics as a huge field of mathematical structures. Field in a similar sense like physicists say about gravitational field or electrical field. So it is not a system of logical system, it's something different. So mathematics will be a field of mathematical structures, and if we have axiomatic system, we cut off from that huge field just a small part, and then all paradoxes can arise, of which the theorem said. I would willingly expand this this idea, but I think it's not time for.
But you always emphasize that the world is mathematical, that's a fundamental property of this universe. Therefore, if it is mathematical, it should be subject to Gödel's theorems.
Firm belief, as Guy would say.
Excellent. I know Andrzej Dragan wanted to give us a short remark and a question.
Thank you. So if you take a piece of paper, much bigger than this one, and fold it in two, and then fold it again, and again, and again, each time you double the number of sheets, and pretty soon you'll end up with a pretty thick stack of paper sheets. And if you ask anyone what is the thickness of that piece of paper after you fold it 50 times, a typical answer is that it may be 10 centimeters, 20 centimeters, while the correct answer is that the thickness of that paper will be equal roughly to the distance between the Earth and the Sun. So us humans are painfully wrong about the simplest possible questions that only involve the ability of multiplying by 2. This is already too difficult to most of us. And what about smart people, like the smartest alive, Albert Einstein, the smartest who ever lived? So essentially, there are two types of questions, easy questions and difficult questions. And science is only about the simple ones, the simplest possible, because these are the only ones that we can even try to attempt to answer. And an example of such a simple question is, what happens if you empty the entire universe, leave only 2 infinitely small balls, and let them move? What's going to happen? These are the questions that physics can ask. And in fact, this question is worth of a Nobel Prize. Like 4 years ago, after the discovery of the gravitational waves that were the effect of collision of 2 black holes, those waves were detected. And this is exactly the problem I described. What happens when you have 2 infinitely small points that move around? So these are the questions that science can ask. And this discovery was announced by the press as the huge success of Albert Einstein, who was the father and mother of relativity. And the irony is that Albert Einstein did not believe in the existence of black holes. He doubted the existence of gravitational waves, although both of them are natural logical consequences of his own theory of relativity. He also doubted, and he was wrong about that the universe is expanding, although this also was a consequence of his own theory. He questioned that the humanity will ever use nuclear power, although only a few years later we had the explosion of the atomic bomb. Because of his beliefs in how the nature should be, he was also completely wrong about quantum theory. So we are talking about one of the greatest minds that ever lived, who was constantly wrong about extremely simple questions within his own area of expertise, which is shocking. But this only shows how easy we make mistakes. And that's why science is built on doubt. And here, you are addressing very, very hard questions, the hardest possible, about the meaning of life, about the origin of the universe, about the nature of God. Don't you think that us daring to ask these questions and hoping that we have anything relevant to say isn't just a sign of our being naive or arrogant?
First of all, I fully agree with you that the task of science is to ask the simplest possible questions. For instance, the question out of which the modern physics was born was the question about how the stone freely falls to the earth, to the ground. It was Galileo and other people who investigated that point were able to isolate a simple question from the entanglement of many other phenomena in the world, and they were able to give an answer because it was so simple question. And this is a seed of modern physics. And if we compare that, for instance, with what happens now in neuroscience, people have to face a huge complicated system like our brain, and it is very hard to isolate the phenomenon which would be a counterpart of a falling stone, something very simple. So it's not always possible to have such a simple point. Nevertheless, we start to have such simple points. This is one of my comments. The other comment is that the fact that the greatest scientists were sometimes wrong, were very often wrong. Sometimes they were right. This fact corroborates my faith in a rational universe. Why? It was, I think it was Hertz or Maxwell who said that equations are wiser than those who wrote them. And this is really the case as far as Einstein equations are concerned. They are huge, very beautiful equations. I always admire the structure, and which is inexhaustible, in fact. And we now know a lot of solutions to Einstein equations, but there are many, many more than we know. And the case with black holes, with gravitational radiation and so on, this is just an instance of that rule that equations are wiser than those who wrote them down. And I also agree with you. It is a wonderful thing, by the way, that I just notice that I very often agree with my opponents. I agree with you that the questions like meaning of life and meaning of the universe belongs to extremely difficult questions, and this is why they do not belong to science.
Mm-hmm. Thank you so much, Professor. Our time is almost up, but we have one more question, this time an online question coming from Simonetta Raski from McKinsey & Company, Switzerland. Simonetta, are you with us?
Good evening, Mr. Haller. Thank you so much for being here with us. To be honest, I'm not very familiar with all the fascinating work you created, but already reading a couple of articles, I found them very interesting. If I understood correctly, like throughout your life and still now, you are trying to answer like major question of our existence. I was wondering, which was those big questions that still remained unanswered for you, and how are you trying to go about them?
It's a good question about important questions, and I don't think there exists a catalog of important or big questions. And if we find out an answer to one of them, we just mark them out and go to another one. This is far more complicated than that. Answering big questions or even formulating them is a process. It's a long process. I would compare this process to reading fancy book. When you approach to the end of the book adds a new pages, and this process never ends. So if you are closer and closer, if you believe that you are closer and closer to the answer to one of the questions, the new big questions are generated, and the process keeps going on. And I think this is exactly what distinguishes big questions from simple questions.
Thank you so much, Professor Haller, for being with us. I wanted also to thank our marvelous guests here in the studio and those who joined us online for this part one of intensive and extremely important discussions on the question of space exploration, the meaning of the universe, the questions of religion and science, where do they interact? But this is only the first part of our masterclass. Now we will take a short break, 10-minute break to refresh. In this 10-minute break, we will present to you also our partners who made today's masterclass possible. A whole heartfelt thank you to these partners, of course. And after a break, we will meet another set of fantastic speakers. We will meet Professor Jeffrey Sachs from Columbia University. We will connect with London with Kate Rafford, who is the author of the Donut Economy book. And last but not least, our artificial intelligence expert, Mike Walsh, who will tell us what awaits us and whether artificial intelligence can predict the future. It has not predicted our pandemic, so let's see what is in stake here. Ladies and gentlemen, again, thank you for being with us in this first part of our masterclass, and I'm looking forward to seeing you in just 10 minutes.
Hello, my name's Tom DeVries, and I'm the president of the Global Leadership Network. And I want to say how excited I am about raising the bar of leadership in all sectors of society. See, because the need for good leadership is everywhere. See, the leadership we know is not enough, and we need to have new strategies and a new generation of leaders. Humility makes it possible for us to hear and to grow. With enough humility, the older among us can learn from the younger, and the younger can learn from the older. See, leadership is influence. Everyone has influence. You have influence. I hope that you would invest in your own leadership. Everybody wins when leadership gets better.
I would say the vision of the World Youth Alliance is of personal excellence. You see all of these young people from all around the world. They care about others. They care about the world.
We all have the same mission because we all want to change the world. We all want to change our societies.
Everyone's talking about human rights, but no one knows why they're protecting them.
They're looking for answers. Who am I? Do I actually matter?
It's definitely an urgent time to point out those inconsistencies in our different ideologies and show that we need to be consistently affirming the value of human life at all levels. Otherwise, we all become vulnerable.
Organizations like World Youth Alliance have to exist because there's a constant need for someone to stand up for the little guy, the person that has no voice, and that's what World Youth Alliance does.